All right. All right. So first of all, I will explain why I was on yesterday. So I over the summer was having some health issues with like dizziness and stuff, and then the school started like over the summer too. Like if I'm just sitting there, I can feel like weird things in my heart, which isn't good, you know. So last Friday, that's why I was gone, is I went to the doctor to check that out. And she was like, yeah, I think everything's okay, you know, whatever. So fast forward to yesterday morning, I get up and I'm in the bathroom and I just turn my head like this and I just pass out, like just bang on the floor. So then I come up to, and my daughter is a nurse and she works nights at the hospital, and in my mind she was working, but really she's at home now. So really she was just like 2 bedrooms away. But I text my husband first, who is a teacher in Sauk Rapids, and I'm like, instead of calling, I text him, I just passed out in the bathroom, call me. So then I text my daughter, thinking she's at work, same thing. Well, my husband is getting gas and like drives to work, knew I texted him but didn't know what I said. And then all of a sudden it occurs to me that my daughter's home. So I go into her work and she knew about these other things that had been happening. So I walk in and I'm like, Cam, I just passed out in the bathroom. And she's like, what? I'm like, yeah, well, what do you think I should do? Should I go to work and just see what happens? And she's like, no, you need to go to the ER. So here's the really stupid thing. I finally get a hold of my husband and we decide he's going to meet me at the ER. And I drove. Like, isn't that stupid? But here's the really stupid thing. My daughter had training at the hospital and she left a half hour after I did, and I could have just gotten a ride with her. Never occurred to me. I was just like, I want to go, I want to get this done, and I left. So then they ran all these tests, and so far nothing showed up, and I have a heart monitor on right now, and hopefully it's nothing big, but I have to wear this till Friday, and then we'll see if anything shows up on that. My 5th-hour class will be the real test because they're foggy. So today I'm probably whenever my like heart does something weird, I have to push a button. So I'll probably be pushing it 100 times in class today because they can get kind of naughty. But yeah, I don't really know what's happening, but hopefully it's nothing major. Okay, so today we are going to talk about polyhedrons, and we are going to go through like half of section 1A, and then tomorrow we're going to finish section 1A, which will only have like 1 page, and then what I teach out of section 110 is really short. So I'm hoping I'll have enough time 2nd hour tomorrow, because I believe 2nd hour 9th graders go and 3rd hour 10th graders go to that career fair. Is that what you guys thought? Or don't you know? Anyway, I'm hoping I have enough time to teach that, and then Friday we would do the practice test and then we would do the test. Okay? So first we need to talk about what is a polyhedron. And a polyhedron is anything that has flat face. These are called faces. Anything that has all flat faces. It's going to have straight edges. It's going to connect at what they call vertices. That's what a polyhedron is. Something that is not a polyhedron is going to have curves like this. Okay? So, one of the things that's going to happen today is there's going to be the majority of your homework actually is going to give you a figure like this, and it's going to say, is this a polyhedron? And you say yes or no. It's going to ask you to name it, and I'll show you how to do that. And then it's going to say, name all the faces, edges, and vertices. I don't make you do that because to me it's kind of busy work, so this is what they would want. They would want you to name all of these planes, okay? So this, if it had 3 vertices, you can name any of those, call it plane whatever, plane whatever, plane whatever, and so on. Then you'd have to name each of these edges, and then each of the points where the vertices are. But if it asked you to do that, you do not have to do that. Okay? Now, if we look here, the first thing that we're going to talk about is 2 different types of polyhedrons. And the first one is a prism, and the second one is a pyramid. These are both polyhedron because they have flat faces, okay, no curves. This is a prism, this is a pyramid. So I want to explain the difference. A prism has 2 sides that are across from each other that are going to be the same, and then it's going to have rectangles going around, okay? So a prism is always going to have 2 bases. Then if you look at a pyramid has 1 base, and it goes up to a point, and it has triangles going around. Prism has rectangles going around, pyramid has triangles going around. So the first thing we're going to talk about is our prisms. Okay. So when you guys learned about these, you always learned of this probably as a cube. But for today, what you would call this is a square prism. Okay? So one of the bases is a square. Actually, all of the bases are squares. So this is a square prism. This one, notice, has, depending on how you look at it, where you call the bases doesn't really matter. But this one you can't call a square prism because all 6 sides are not squares. You need all 6 sides to be squares for it to be a square prism. So this would actually be a rectangular prism. Okay? Here, this one has the rectangles going around, and notice this is a triangle, so this would be a triangular prism. Okay? And then this one is a hexagon, so we would call this a hexagonal prism. Okay? Hexagonal prism. Alright, so the next thing that we are going to talk about, Alexis, can you take your phone off this, please? The next thing that we're going to talk about is pyramids. Okay? What's Alexa's last name? What is it?
Elias.
Elias?
I think so.
those are all polyhedrons. The rest of what we have here are going to be not polyhedrons, and that is because they have curves. So these are much easier to name. I think you all know this is a cone and this is a cylinder. They have curves, so they're not polyhedrons. And then the last thing is this. And this is a sphere. Okay? Do you guys know what half of a sphere is called? Hemisphere, yes. Okay. So now, if I went back up here, what do you guys think we would name this? Do you get it? Yeah. This is going to be a pentagonal, because the base is a pentagon, and then prism. Okay. What do you think this one would be? Does that bottom look like a square? Or does it look more like a rectangle? I would say it's more like a rectangle. So I would call this one a rectangular. And then it goes up to that point. It has triangles going around. So that one is a pyramid. Okay? Now, if we look at example 1, a lot of your assignment today is this, and these go really, really fast. So the first thing you're going to answer is this a polyhedron, yes or no? The second thing is you're going to identify it. And what I mean by that is pentagonal prism. Okay? This right here is the part you don't have to do on any problems. Okay? So if it says name the bases, faces, edges, ignore that. So if I look at A, is that a polyhedron? Yes, it is. It's all the sides are flat. Does anyone know the name of it? It would be a rectangular, and then it's a prism. It's got the rectangles all around. Is this one a polyhedron? No, and the name would be a cylinder. Okay. This one has a triangle base and then triangles going around. Is it a polyhedron? It is. Does anyone know the name? Yes, triangular pyramid. Okay. Now if we look here, okay, is that a polyhedron? No. And what's the name of this one? Very good. These are easy to name. And then down here, this one some people mix up. First of all, it's not a polyhedron, right? It is a polyhedron. It has all flat sizes. Do you guys know the name of this one? Yeah. So it has these two triangles that are your bases, and then it has rectangles going around. It's this one right here. So it's like sitting like this. It has two triangles and then rectangles going around. So it's a prism. Remember, a pyramid has one base and goes to a point. A prism has two bases with the rectangles around. Okay? So this one would be triangular, and then a pure prism. Okay? If I go down to this one, is this a polyhedron? It is. Anyone want to take a shot on the name of this one? Yes, hexagonal prism. So that is what the majority of your homework is like, is just this, okay? Now, what we have left is we are going to learn between today and tomorrow how to find surface area and volume of different figures. Okay, if I had a figure and I asked you to paint it on the outside, am I talking surface area or volume? Surface area. If I'm just painting the outside, surface area. If I'm asking you how much water fits in here, that is when I'm talking volume. Volume is the space inside. So on that cheat sheet that I gave you guys, you had already the formulas for circumference and area and perimeter. On the back side, we have the formulas for prisms, pyramids, cylinders, cones, and spheres. So that's what you're going to want to have out today. Okay? So, first of all, I want to tell you that when you guys first learned how to find surface area of a prism, it's very likely that what your teacher had you do is find the area of one side and multiply by 2. Then find the area of this and multiply by 2. Find the area of this and multiply by 2. And then add it all together. And that's surface area. And you still can do that. The reason I'm showing you a little bit different today is that the formula for a pyramid uses the same letters as prism, and I like you to get used to this, and then it makes this one so much easier. But it is true, and you could do the way I just told you, and if you did that, you may want to add on here, this would be your length, this would be your width, and that would be your height, okay? And another way to do volume of a rectangular prism, is you could do length times width times height, which again is how you probably figured that out when you were in middle school and maybe even later elementary, okay? Another thing, when you do this one, the volume of a pyramid, if you wanted to write this down, you could do 1/3. Let me think about this, length times width. That one's harder, so I'm actually not going to do that. We'll not talk about that because that one's a little bit harder to do. Okay, now we need to ask, like, what are the P, the H, and the B? So when you're doing a prism, you always are going to be doing a rectangular prism for this part of it. I wouldn't give you a triangular prism or anything like that. And what you would do is you would mark what side you want your base of it to be. And I always choose the bottom to be my base, okay? Now if you guys notice, P is the perimeter of that base, okay? Which, if you guys wanted to write this up above, okay, the perimeter, you're just gonna go L plus W plus L plus W, okay? That's pretty easy, right? When you go to do, I'm gonna skip over to this capital B. The capital B stands for the area of the base. And I think you guys know that if you're finding the area of a rectangle, it is length times width, okay? So you're gonna find the perimeter just by adding around. You're gonna find the area of the base just by going length times width. And then if you notice in this formula, there's also an H. And H is always this. It's how tall it is. Okay? So H is always how tall your prism is. So if I was doing this and this was my base, my height would be this. Your height is also whatever number is not included in your perimeter and your base, because you're using just these numbers for that. The height is the one you haven't been using. Okay? So then we have a pyramid, and I'm just going to talk about this real quick, and then we're going to do an example with this. But one thing I would like you guys to write on here is whenever you have a pyramid, it's always going to be a square pyramid. Okay, so every pyramid that I give you for this part is always going to be a square. And then this right here, because it's a square, do you guys understand that all of these sides would be the same? Does everybody get that? And like, let's say I called each of those S for side, okay? Your perimeter then would be 4 times whatever that side is. And the area of your base would be side squared. Okay. Now, another thing I want you to notice is in the surface area formula, there's an L. In the volume, there's an H. A pyramid and a cone, that we'll talk about tomorrow, have 2 heights. So we're going to go down to this diagram right here, okay? So a pyramid has what we call the perpendicular height, which means it's straight up and down. And it would look like this. If I could connect the top point to the middle of this square on the bottom, there would be a line inside of this that would be perpendicular to the bottom. It's this height right here, and what our book calls that is H for height, okay? That's what they want for this. That's the perpendicular one. When we do the surface area, they also give us a slant height, and what that would be is if I connected this point with like a midpoint of this, and I drew the line right on this face, and I drew from here to here, that line would be slanted. And what they call that is a slant height, and they use a cursive L for that, okay? So the H is straight up and down perpendicular. The L is our slant height. Okay, so now what we're going to do is go and try to do our first one, okay? So for today, you may have to do prisms, and they'd all be rectangular. You may have to do a pyramid, and that would be a square pyramid. So when I go to start this one, you guys, I always choose what my base is, okay? So this would be like your length, this is your width, this is your height, okay? Now, the formula is right here that I'm going to show you to use. And the first thing we need is P for perimeter. So whoops, I think I'm going to draw it. You probably don't have to do this, but that base, if we drew it down here as a rectangle, the top and bottom are 10, and the 2 widths are 5.2. And when you go to find the perimeter of that, you just add a round. So if you went 10 plus 10 plus 5.2 plus 5.2, you would get 30.4 for your perimeter, and that would be in centimeters. Okay. Then they ask us for capital B, which is the area of the base, and I had you guys write here that it's the length times the width. Okay, so if I come down here for it, B is length times width, so I would just go, this was my length, this was my width, and I would just go 10 times 5.2, which is 52. And that is area of your base, so it's centimeters squared. Okay? So now I know what my perimeter is, and I know what my capital B is. And now I can go and find the surface area of it. So if I go to do that, okay, surface area is the perimeter times the height plus 2 times the area of your base. So the perimeter is right here. That is the 30.4. Now, the height is how tall your prism is. This is your height. How tall your prism is. So that is 6. And then it's plus 2 times the area of your base, which is the 52. And if you go ahead and punch that in, if I go 30.4 times 6 plus 2 times 52, did you guys get 286.4? And that is in its surface area, so it's centimeters squared. Okay? Now that you found that, it's easy to find the volume because you already know what B is and you already know what your height is. So all we have to do is substitute in. So if I look, my volume is the area of my base times the height. The area of my base again is 52. The height is how tall my prism is, and that is 6, and that is gonna come right here. So it's 52 times 6, which is, did you guys get 312? I believe, and that's centimeters cubed. Everybody okay with that? So that's a prism. Okay. Now let's go to the next page. This will be our last page. Your page might look. Did I ever give you notes today?
No.
Should you do? I might as well give them to you because you'll need them tomorrow. You guys, if I ever do that, just holler. Please don't hesitate to tell me if I forgot. I think I'm getting old, you guys, 'cause I never forgot this much last year. Maybe I need to retire. I told my neighbor yesterday I think I should just sleep in every day and eat bonbons. She had lots of good ideas. But then she reminded me I married a teacher and I get married for money. Alright, sorry about that, you guys. Okay, so let's try this again. So now we're on the pyramid, and again, whenever you guys have a pyramid, it's going to be a square pyramid. We could not find the surface area or the volume without it. Okay? So what you can assume then is that all four sides of that is a square on the base. So what that is then is 6 by 6 by 6 by 6. And here's another thing. When you are given a pyramid, there's two heights. Do you remember what letter we use for the one that's straight up and down? That's our H. And then the one that's slanted or on this is L. So L is the one that's slanted, okay? So let's go ahead and put this into our formulas. So the first one, surface area is, now for 1/2, I would use 0.5. And then it's perimeter times our slant height plus area of our base. So the first thing I'm going to do over here is I'm going to find my perimeter, which some of you would go 6 plus 6 plus 6 plus 6. Some would do it in your head. And you also could go 4 times 6. And the perimeter is 24. And that's centimeters. Okay. Now, the other thing that we need is the area of that base. And again with that, this is a square. So you could either think of it, this is a side and this is the side. You can think of it as side squared, or you could think of it as length times width. But you're basically going 6 times 6, which is 36 centimeters squared. Okay? Now that we know that, now we can just go back to our formulas. So, the 0.5 I have, the perimeter is this 24. L is the slanted height, which I have as 5, plus B is the area of our base, which we have as 36. So if we go to our calculators and we go 0.5 times 24 times 5 plus 36, I get 96, and that would be surface area, which is squared. Okay, then we have to find the volume, which is right here. It's 1/3 area of our base times the height. Now this is important, you guys. All year I've been trying to avoid fractions on your calculators, and it's not hard. It's just if I can, I avoid it. But once you get to a fraction that's like a repeating decimal, then we don't like you to use like 0.33, because as your area or your height or whatever you're multiplying by gets bigger, you can be further and further off from the answer. So how, if you haven't ever done it, to put a fraction in any calculator, you can go parenthesis 1 divided by 3 parenthesis, and that is 1/3. If you have the CE version of the graphing calculator, there's another way to get a fraction. You can look that up. Some kids use it, some kids don't. Okay, but there is another way to get that. Then capital B, we found right here to be 36. And then H is the perpendicular height right here, which is 4. Okay? Now, if you go to your calculator and you do parenthesis 1 divided by 3 parenthesis times 36 times 4, it is 48. If you tried that without the 1/3, if you did 0.33, those numbers aren't that big, so you're probably going to be really close. But if these numbers were like 1,000 or something like that, it's not as close. And volume is cubed. Okay? Now, your assignment for tomorrow is this. And then I have to figure out, you guys, tomorrow, like, what I do with sophomores